Welcome to Electronics and Arduino for Kids and Beginners. We're going to cover some basics of electronics, and we're going to cover some basics of Arduino. And by the time we're done, we're going to have created the neat little Simon game. So let's get started. The first thing to talk about when we talk about electricity is the humble electron. Electrons are subatomic particles. All atoms have at least one of them. Some atoms are really good at allowing electrons to come and go, and the ones that do that are said to be electrically conductive. Some atoms don't have a lot of play for the electrons to come and go, and these are said to be electrically insulative. Large atoms that have just a few electrons in their outer shells are most conductive. So here we have gold, for example, and you can see that there's just one electron in this outermost shell for gold, and that means there's a lot of electrons that can come and go, and so gold is very electrically conductive. Another thing to understand is that nature seeks homeostasis. What that means is it wants to be at the lowest energy level possible. It's going to seek balance or a stable arrangement. When we have pent-up electrons on one side, electrical conductor for them to get where they're trying to go, and a lack of electrons on the other side, we're said to have electrical potential. Negative electrons are seeking the positive protons. Electrons are much smaller and lighter, so they always travel to the protons, which are kind of the center of the nucleus. An atom may have many electrons, one for each proton. An atom with a missing valence electron in the outer shell will strongly attract electrons. This creates a chain reaction where electrons will move to fill the void one from another. Next, let's talk about what a circuit is. Circuit literally means circle. Circuit literally means circle. And it creates a path for the electrons to follow. So here we have a battery, maybe a switch. It goes on through a light bulb, goes through the light bulb, comes back and back into the battery. You can see it makes a full circle. A short circuit is still a circuit, but it's one that takes a path other than the one we intend. So here we have a light bulb, which we'd obviously want to light up. But so long as there's an easier path for the electrons to take, it'll take that path. So when we have this happening in our diagram where the electrons are taking a path other than through the load that we wanted to put on it, this is called a short circuit. The next thing we should probably understand is Ohm's law. Ohm's law describes how electricity is going to flow. You can see we have kind of the nature in this triangle here. So I is the symbol for current, R is the symbol for resistance, and V is voltage. So if we times our current times our resistance, that's the voltage we would expect to get. Or if we have a known voltage and we know the resistance, we can divide the voltage by the resistance to get a known current. Voltage is kind of like the pressure. So if we're taking a water hose, for example, a voltage would be how much pressure we have. Amperage is how much flow we have. So do we have just a small hose, or do we have a river of amperage, or the river of water? You can have a river that's not at very high pressure, and you can also have very high pressure in a really tiny place. So they're kind of independent. And resistance is just like it sounds. How difficult is it to flow? Is our hose kind of kinked up, or is it easy to go? So here we go. Here's a really simple circuit. We've got a voltage supply. We're going to assume 5 volts in this case. We've got a 300 ohm resistor, and we're kind of curious about how much current is going to flow through this circuit. if we take the V equals I times R, Ohm's law, and we say we know the voltage is 5, we're looking for current, and we know this is a 20 ohm resistor, we can then divide out this from both sides. We get 5 divided by 20 equals amps, or 0.25 or a quarter of an amp. When we combine different resistors in a series circuit, one after the other in series, then it turns out that the the resistance of R1 plus the resistance of R2 is the resistance of the circuit cumulatively. So it adds up. So if R1 is 5 ohms, R2 is 15 ohms, then the total of this circuit is 20 ohms. There's also something called Kirchhoff's law, which is basically any voltage we put into the circuit is going to be what comes out. So if I have 5 volts to drop, the resistors are going to drop a total of 5 volts. So therefore, if we add a third resistor in line here, then the voltage between each of these is going to drop proportionally to whatever that third resistor is. Parallel circuits, on the other hand, have kind of an opposite effect. Their total voltage is 1 over the voltage 1 plus 1 over voltage 2 plus 1 over the voltage 3. All this to say is that when we have a parallel, see, it's parallel because the positive is all on this side and the negative is all on this side, rather than daisy chaining like the series circuit here. When this happens, the resistance actually drops. So if we have 25 ohms of resistance in this load and 50 ohms of resistance in this load, the total resistance for this whole circuit is going to be something like 16 ohms, which is less than either of them. So if we put resistive loads in parallel, we're actually dropping the resistance. And let's talk for a second about LEDs, as we're going to be using these in our project, and they're very common components. LED stands for light emitting diode. A diode is a passive component that allows electricity to flow just one way. It has an anode and a cathode for the positive and the negative. But the weird thing about LEDs is they are not a resistive load. They have a voltage drop kind of like there is a resistive load, but after that voltage drop, it's essentially like there's little or no resistance. It's like a short circuit. We must always have a current limiting resistor when working with LEDs. And we'll show that in a second. So now let's start playing with some circuits. If you navigate to TinkerCad.com, I'm already logged in. If you're not logged in, go ahead and do so. Click on the Circuits tab, and I'm just going to say Create New Circuit. What I normally start with is just a small breadboard. So I'm going to pull this breadboard on here. A breadboard is a really neat component that allows us to quickly prototype things. The way it works is the columns A through E are all connected. And the positive has this positive rail and the negative has this negative rail. I'm going to pull an Arduino on here just as a power source. And rotate that. And then I'm going to use this wire tool here to connect up the ground. And also going to change it to red. And I'm connect the 5-volt source. Oops, change this to red on accident. I want this to stay green. And then these two aren't connected, and I kind of want to be able to pull power off each. So one thing I commonly do is I add a bit of wire going between these rails. So now I'm going to add some red wire. Okay. I'm going to first show you what happens if we connect an LED straight to our power. So I'm going to search for, oh, it's right here, LED. Let me grab this guy and I'm going to rotate him, and I'm just going to stick him right here on the power bus. Positive to positive, negative, negative. You know this is the anode because it's labeled anode, and also it's a little bit longer. If you'll notice, that's how they do that. And if I click over here where it says start simulation, you see that poof? It said the current through the LED was 483 milliamp, while the absolute maximum load is 20 milliamp. So we blew our LED, and that would happen in real life. If I were to plug in an LED like that, it would blow. You might see it flash, you might not. So let's try this again. I'm going to rotate it back like this. I'm going to stick it in here, and I'm going to pull the red over to red, and then I'm going to grab this resistor and I'm going to stick him here instead. I'm curious what the resistance is for this, so let me go actually look it up. If I go do a quick search for LED calculator, there's lots of really good sources here. We know our supply voltage is 5, 1.8 is typical, 20 milliamps is typical, and we just want one, and I just want a wiring diagram. One LED wiring diagram. So what this is telling us that if we have a 5-volt supply and one LED, a 160 ohm resistor is required. The way they get that is using Ohm's law, like we learned about before. If we come back here and we say this is 160 ohms, and then we start the simulation again. Oh, I had a problem here. I need this on negative. There we go. And we start the simulation again. You'll see my LED is no longer blowing up. It's nice and bright, but not blowing up. If I put a higher resistive value on here, say 160 kilo ohm, this LED is much dimmer. So now what I want to do is introduce a push button. So I'm going to pull one of these over, and the way these work is when the button is pushed, it connects terminal 2 to terminal 1. So I need to move this wire, and I'm just going to reroute it up here such that it's connecting into the top of this. So now the circuit goes from here up this wire to here, where it's going to wait for us to push the button. When the button's pushed, it's going to connect through the button to here, and we have a connection to the anode, and then the cathode is still connected via the current limiting resistor to ground. So if we simulate this, pretty neat, right? So when I push the button, it lights up. That's pretty neat and all, but let's now drive this LED with the Arduino in code. So I'm going to take away the button. I'm going to take away this line for a minute, and I'm going to borrow pin number 8 and connect it to here. What this will do is pin number 8, when turned on or pulled high, will then supply power to the anode, and the cathode is still connected via ground. If we want to see the code for the Arduino, what we do is we click on it, and then there's this code button up here. So we're going to toggle code editor. And if you've seen any of the demos we've done on Scratch, you'll know kind of how these blocks kind of work. So what I'm going to do is basically set pin number 8 to high. Then I want to wait 1 second. And then I want to set pin 8 to low or off. Then we need to wait another 1 second. And then when we run this, it should flash 1 second on, 1 second off, 1 second on, 1 second off. What's happening here is this is inside of loop command. If I go stop simulation and I look at the text that it generates, we can see in the C++ code, there's this loop function where it's going to do this over and over again. That's why it keeps on going. The setup function is another interesting function. This gets called just once, but that's how we set that pin as an output pin, pin number 8. And then loop is called continuously. So here we're raising the pin 8 to high, waiting 1,000 milliseconds, which is 1 second. Then we're putting the pin to low, and then we're waiting again. So that's how the Arduino code works. The next thing I want to show you is how we can use a button as kind of an input device. So what I'm going to do is pull over a button, and I'm going to connect it to pin 9. And then on the other side, I'm going to connect it to ground. And I'm going to make sure that this is green so we can see what's going on. Ground. Okay. I'm going to change the code now to only show that LED when the button is pressed. So I'm going to get rid of this code that we had here. And I am going to pull this read digital pin, and I'm looking at pin 9. And I need this in a math statement. And what I'm doing here is read digital pin 9 is equal to high. And we're going to put this in an if statement. Get a little more room here. So if the read of the digital pin 9 is high, then we're going to do something. And actually that is wrong. I need to check to see if it's low because we're going to pull it down. So a little bit more. So I'm setting pin 9 to high. Then if it's low, then I want to turn the LED on. Here we go. So I want to set our LED, which is on pin 8, to high. Actually, I really want an if else, so I'm going to swap this out. I want that and the if, throw that away. And if it's not pulled low, then I want it to turn back off. So I'm going to go back to output, set pin 8 to low. So let me go over this real quick. This set pin 9 to high, this is our input pin. By setting it to high, we're enabling what's called the pull-up resistor. When we short that pin out, e.g. when we pull it low because it's connected straight to ground, it's no longer going to be high. So when we read it, it's going to show low. When it shows low on pin 9, we want to make pin 8 high, or we want to turn on the LED. If it's not, if the button is not pushed, then we want to make sure it's turned off. So let's give this a try. And there we go. This is how we do input for Arduino. Okay, so now that we've got this all kind of figured out, we want to actually start building our Simon game. So I'm going to delete what we have on here. And we're going to get set up. The first thing I need is a row of LEDs. So these are going to be spaced 2 apart. And there's a red, a green, and a blue, and a yellow. The red's fine, but we need to change color of this. The way we do it is we click on it, and then come over here and we say this one we want green. Click on this LED, this one we want blue. And finally this LED we want to be yellow. And we know that all LEDs need a current limiting resistor. So let's put those on next. So I'm going to put one on each of these, connected to their cathode, and then to ground. And they're all set it by default to 1 kilo ohm. So we need to change these all to be 160 ohm. Change it to ohm and then 160. Perfect. The next thing we should add are the buttons. So the buttons are going to line up with the anode on the left side. So each of these should have an anode on the left side. And they all need to be connected to positive. So I'm going to change my color to red, and I'm going to just make these little wires on each side here of this button. And lastly, we need to add a speaker. So there's piezo speaker, and this big boy, let's put him right here. And I'm going to change this to green and do this leg is connected to ground. The last thing we need to do wire-wise for this setup is to connect some of these pins to these buttons and the speaker. Okay, so let's connect pin 9 to our speaker. So I'm going to bring it clear down here. There we go, pin 9. Make that nice and level. Okay. Pin 10 is going to connect to our yellow. Trying to keep it as clean as I can. Pin 11 is going to connect to blue. Pin 12 is going to connect to green. And finally, pin 13 is going to connect to red. And with that, all the circuitry we need for our Simon game is done. That's all we need. So now all we have to do is supply the code. Now, unfortunately, we can't do all this code in blocks. So in order to get the speaker to work correctly, we're going to have to abandon the block-based stuff and move to text. When we do blocks plus text, it shows us the code here. And this one's kind of read-only over here. If we go just to text, we get this dialog saying that once you've converted the text, that's it. You can't convert back. So that's okay. We're going to say continue. It's idiomatic in C++ to use pound define to define kind of what things are connected to. So I'm going to pound define red as being 13, e.g. it's connected to pin 13. I'm going to do likewise with green, blue, and yellow. And then finally, our speaker is on pin 9. Next, we're going to add some local variables. Game over is whether or not the game's over. Game mode is whether or not we're tapping the sequence or whether or not they're supposed to enter it. Then we need a variable for the sequence itself. The sequence is actually an array, and we're going to allocate 50 integers to this array. And then we need another variable to say how many of those 50 are actually in use. So we have another integer for sequence length. Just a couple more variables for setup here. We need a variable called buttons, which is an array that's just 4 long, and it's going to equal red, green, blue, and yellow. And this is going to be helpful for us later when we are trying to figure out which buttons to show. And then we need one other thing is we need to know the tones that we are going to play for these in terms of what frequency. So I need to go back up here for a second, and by this pound speaker we need to define tones for each of these. So I want to define red tone, and we're going to make red equal 200. We're going to make green 250. Blue tone is 150 hertz. Yellow is 300 hertz. And then last, game over is 100 hertz. And then I want another one for tone duration. I want to be able to adjust that easily. So, and we're going to create that as 300 milliseconds. Okay. And then next thing we're going to do is something called a for declaration. Because we want to be able to run these in any order we want, we need to tell the compiler what the functions are we're going to use ahead of time. So let's do that. I need to start with a function called setup as outputs, setup as inputs, run sequence, and read sequence. Now we have those declared, we can add them at any place. Let's just kind of copy these down here, And then each one of them will need to remove the semicolon and do open and close curly braces. Perfect. In our setup, we do need to do a few things in here, but let's get rid of what's there. We want to set game mode equal to 0, game over equal to 0, sequence length equal to 0. The next thing we need to do is we're going to be utilizing a random function, and for random to work correctly, it's a little bit weird, but we have to read a pin that we're not really using, and we need to read it as analog. So the way this looks is going to be random seed with capital S, and I'm going to do an analog read of pin A0. And because we haven't set this pin up or done anything with it, it's what's called a floating pin. We're going to get a value between 0 and 1023 on it when we do an analog read of A0. And it's going to be kind of random. So this is perfect for our random seed. And then we're going to set pin mode for our speaker to output. And that's all the setup we need. In the loop, I'm going to get rid of everything but the delay, and in fact, I'm going to increase the delay. I'm going to make it configurable, so I'm going to add yet another pound define for delay time. And I'm going to set this to half a second, or 500 milliseconds. There we go. Our loop is going to be pretty simple. It's going to simply be while game over equals 0, and then if game mode equals 0, then we're going to do that. Else, we're going to do that. And what this is going to be is playing back of the sequence. And this is going to be, let me move this in here, sorry. Play back the sequence, and inside here we're going to read sequence. Here we go, run sequence. And this is going to execute that method that we're defined below, but don't have anything in yet. And then there's the read sequence. Oops. That I'm also going to copy and paste here. And believe it or not, that's all there is to the game loop itself. Now all we have to do is define these plus one other, but set up as outputs and set up inputs. The reason I've got to have these is because sometimes we're going to be listening for buttons to be pushed, and we're going to read those buttons out. But sometimes we're also going to be using these outputs to light up these LEDs. So we're going to swap between them frequently. So I'm creating just these two functions to do that. So for set as outputs, we're going to say pin mode red output. We can copy this for the other colors. Red, green, blue, yellow. And then, as you might guess, we just need to do the reciprocal for the set as inputs. So we're going to copy and paste it, and instead of output, these need to now be inputs. Okay, so for the run sequence, we're going to flash these lights based off of the sequence. So we need these set as outputs. So the very first thing we need to do is call output, set up as outputs. Okay, from there, we need to run through the current sequence. Then we need to add one. Add a new item to the sequence. And then that's all we do here. So we're just going to do a little bit of shortcut logic. We can say if sequence length is greater than 0, because if there's no sequence to run through, then we can skip this part. Next, I want to do a for loop. Okay, what this is doing is we're initializing a variable in the first segment of this. We're creating a variable that's an integer named index, and we're setting it to 0. Then the next part of this for is going to check to see if this evaluates to true. As long as this evaluates to true, it's going to loop. And once our index is no longer less than our sequence length, then we've been through all of our we've been through all of our sequences. And then this last statement is the increment. So this allows us to increment by 1, which is what that plus equals, or plus means. We're going to increment by 1 our variable index. So this happens first. Then this check gets done, and if this is true, it executes what's in here, and then it increments and does a check again, increments, does a check again until we're done. So what I want to do here is blink the LEDs. So I'm going to do a digital write, capital W on write, and I'm going to use whatever is in my sequence array, and I'm going to set it high. I'm going to put a to-do. We're going to come back here and we're going to play the tone. But in the meantime, I'm going to simply say just delay a period of time. And then I'm going to take this same pin and I'm going to turn it off. So we're going to turn it on for some time, and then I'm going to turn it off. And I need another delay, otherwise it'll go too quickly. So next, all we need to do is add one to the sequence. So let's get a new value. And what this is we want a value from 10, and this is an inclusive lower bound, so 10 is a valid random number that can come out of here. And then we want it 10 through 13, but 13 is an exclusive bound, so we're I'm saying 10 plus 13 plus 1, just so it's clear that we want all of these. Okay, after I got this random number, I'm going to say sequence length plus plus equals next value. And what this is doing is I am storing into our array at the next available spot. Because our arrays are 0 indexed, we're going to, if the length is 1, then 1 is the next one. If it's 0, the sequence length is 0, then the length is going to be 1. But it's not going to increment until after we've indexed it. So this is going to call increment after we've set the new value, which is what we want. And now all we need to do is do the same logic to play the tone. So we're going to do digital write new high. We're going to delay. We're going to put the note on here, play tone instead. And then we're going to turn off whatever LED that is. Finally, when we're done with the playback part, we need to switch to game mode so it can start doing the read sequence. So we're going to say game mode equals 1. And at this point, we should be able to run this code. Let's see what happens. Okay, so it doesn't like something here. Yep. I used next value instead of new value, so I'm gonna fix that. There we go. Let's try it again. Okay, I don't know if you saw, but that blue LED flashed. Let me hit reset here. And the yellow flashed. Reset here, yellow flashed. Then the red. So our code is working. Let's do the read sequence now. First thing we need in the read sequence is we need to set these buttons up as input. And then we need another local variable to tell us where we're at in our progress for them playing it back. So we're going to say int sequence progress equals 0. And we need another for loop. And this is going to be pretty much exactly the same as the for loop above. So I'm going to copy it. In this for loop, though, we're going to have to read each of these buttons out, and if any one is pressed, at that point we're going to need to evaluate whether it's the correct button. So I need a few variables. I'm going to define them right here. Int red, green, blue, yellow. And I'm going to say and this is just a fancy way of saying these all equal 0. And we say while red equals 0 and green equals 0 and blue equals 0 and yellow equals 0, while they're all 0, we want to read the state of the pins. The way we do that, we say red equals digital read red. Green equals, you guessed it, digital read green. So I'm just gonna actually copy just to save me a little bit of keying out. Red, green, blue. Gotta fix this one to green. And finally, yellow. Okay, so this loop is a nice tight hot loop. It's going to do nothing except for read the state of these buttons. And because it's kind of a really tight loop and this is just an emulator, it needs a little bit of a break. So we're going to do a delay of 100 in here. But if we're going to do this in an actual Arduino, we probably don't need that. The next line of code, I admit, is not pretty. But we need to check to see if the button they pressed was correct. We know that by the time they get to this point, some button has been pressed because they can't get out of this while loop until something has been pressed. Now we just need to see if what was pressed was what we expected. So we have this if statement. Sequence. Yep, it's index. Okay. Sequence index. Not equal and what I'm putting in here is something called a ternary expression. So I'm going to put these in, and then I'll explain what they're doing. So red, green, blue, yellow. And then put the curly braces on here. Okay, what happens here is when I digitally read, and let's say I push down the button on red, this is going to be 1. But let's say I digitally read and it's green and the button is not pushed, that's going to be 0. So what this is going to give me is if red was pushed, that's how we know it's greater than 0, then I want the value for red to be checked against this array. Since only one of these is going to be pressed at once, I can just add it. So otherwise, 0. So 0 plus is green pushed. If green is pushed, then I want the value for green, which as you'll recall is 12. Otherwise, I want 0. Plus, if blue is pushed, then I want the value for blue. And when I say value for blue, I mean the pin number of blue. And that's what we're actually storing in the sequence, is the actual pin number. So if they guessed wrong, make this not a to-do. What we want to do is say game over equals 1. Then we want to play our tone when we get to that point. And then lastly, we're going to break out of this for loop. Okay. Lastly, we're going to do something called a debounce. The reason we have to do a debounce is if we don't give a little bit of space between button pushes, me pushing the red button for too long will result in a multiple red buttons being pushed all at once. So we need something called a debounce. And in real life, another reason for this is buttons are a little bit of an imperfect conductor. And if you look at this in something like an oscilloscope that's showing you the actual current on a button, you'll see that it actually kind of bounces up and down a couple times before it goes high, and sometimes the same for going low. So we just need to wait a little ways, but we also want to play the tone for the color. So that will eventually be our debounce, but for now we're just going to do delay what is it? Delay time, yeah. Next, we're going to increment our sequence progress. Are we even using that? I don't think that we are. So never mind on the sequence progress. Let's just remove this. Sorry about that. And then once we've made it all the way through the for loop in one piece, if that is the case, or whether or not we made it through the for loop in one piece, we want to change the game mode back to 0. And we need to delay a little bit. The reason we need to delay a little bit is if they got the sequence wrong. Actually, no, we don't need to do that. I'm going to take that out. Game mode equals 0. That's where we're going to end. Okay. So at this point, this should actually be a functional game. Let's give it a go. All right, let's see what I have here. Okay, yep, I've got a missing close parenthesis there, so I added that. Okay, and let's restart it. And it started with the blue, so we hit blue. Blue, red, so we hit blue and then red. All right, well, sorry about that. I figured out the problem I had, and it is that this line of code actually needs to be inside the for loop because we need to zero out these each time we go through the for loop. Otherwise, it thinks I'm getting the same sequence twice. And with that one change, we should have this running pretty good. So let's try it. Okay, so we got green, so green, green, red, green, red, red, green, red, red, green. Okay, so clearly it's working. There's just one more piece we want to add, and that's some sound. And so let's get going on that. I need to add another function prototype for the sound. And we're going to call play tone. So just like the others, I'm going to copy this prototype, move to the bottom, get rid of the semicolon, put some curly braces around here. And this is going to be a little bit more simple than I initially envisioned. What we're going to do is simply delay the number of milliseconds specified here. So if we say actually before that we want to digital write to speaker high, another delay, and we need a duration for this as well, which I forgot. So let's add that. We need to add it in our prototype as well. Here we go. Okay. And I'm just going to do a little bit of quick math. The duration is going to be in milliseconds, so I want to just see how many values fit into duration. So okay, and for tab these in. Okay. Now any place where we have the play tone, we need to just replace with this. And I also need to change what I had for my tones. These I put in absolute frequencies, but instead I'm going to be a little bit easier on this code. So we're going to say game over tone is 1. For blue tunes 3. Okay, so red tone we're going to do is 2 milliseconds, green tone 4, blue tone 3, yellow tone 5. And the tone duration, we're going to keep it at 300. So let's just test to see if this works. I'm just going to write here, do a play tone, and we're going to say red tone and tone duration. So when I start this up, I should hear a tone. And I did. Okay, perfect. So we know our play tone is working. Let's get rid of it out of the setup and let's go put it in places where it should be. So here we go, we have a to-do play tone. So instead of this delay time, I'm going to just play the tone. But it's not going to be just the red tone. I need to play whatever tone is that sequence. So I'm going to need to make another variable. So let's come up here for a minute. I'm going to make this array of integers, and I'm going to make it 14 long. And I'm going to prefix it with zeros. And you'll see why in a second, but let me see. I need 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I need red tone, green. I'm going to put this on a new line. Green tone, blue tone, and finally yellow tone. This way I can index directly into this array, and I'm wasting a little bit of space here, but not too much, and it's going to simplify my code a little bit. So come back down here, I'm going to say tones, and we want the index of whatever this sequence points to. E.g., this is going to say precisely what pin it was that was chosen for the sequence, and we want the tone for that pin. So that's what this is going to do, and we shouldn't need this delay any longer, so I'm going to get rid of that, and I'm going to get rid of the to do as we are now playing the tone. I'm also going to copy this down to this other play tone, and instead of sequence index, I can just do new value. Okay, so let's get rid of this play tone here, and we want to actually play the tones while they're tapping out the sequence as well. So instead of this delay here, we're going to play our tone. But we don't know what tone quite as well. So unfortunately, this is going to get a little bit ugly, where we're going to have to grab this into a variable, get rid of this superfluous thing there, and then so if sequence does not equal button, and then tone button. Okay, let's give this a go. We need to play the end game tone too, so let's do that. So if they get the game over, it's going to be game. Let's see, what would I name it? Game over. And I want to do like 3 times the normal tone duration for that. So that should be our last piece of code. Let's see if this all works. Oh, I have too many here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yep. I need this to be 15. Okay, so we heard the tone sound. Okay, so there's not enough delay between the two after we're done reading the sequence, so we need a delay here, and it should be this delay time. Okay, let's try this again. Okay, and we can see I've got a bug. This really should have been 14, and I need to get rid of one of these zeros. So let's try this again. Okay, and you saw that that got the green twice, but there was no break between it. So we need another delay. Let's see. Right here. Okay, I want it to get to 2 in a row, so I'm going to reset this. Okay, no, it didn't work. Okay, so let's stop and think here. Why didn't that work? Oh, we do want that there, but we also want it here. Let's see that. Okay. And you can hear there's now a space between each of them, which is what we want, because if it repeats, we want to be able to see it flash twice. So now our game is complete. Just kind of gonna scroll down here on the code just to see if anyone missed any sections. I'll also post it. But this is a pretty complete and fun Simon game. One way you could maybe enhance it is make a switch here for like a 2-player mode, or actually, we forgot to try if we hit the wrong button. And you can notice these buttons will turn on, but the sounds no longer work. And I think I want the game duration to be like 10 instead of 1. So let's change that. So, yeah, that sounds like a pretty good. You did that wrong. I actually want to use 1 though. So maybe 1, 2, 3, 4. And I can lower this to 8. And then game over. Yeah, that sounds great. Okay, well, I hope you've enjoyed this presentation. If you have any questions, please let me know. And hopefully one of these days you can build one of these in real life. If not, this virtual one's kind of fun too. Thanks, everybody.